Yeah.
What?
Hey, I can hear you.
Good.
And there's no echo.
Sweet.
That's good. I don't know why I started having one, because the first like 20 or 30 minutes was fine.
That's
And
weird.
nothing had changed.
Oh, and Shaylee, I'll explain to you while she keeps looking. She is saying that the ANOVA, usually they like create the QQ plot on their own, but with the ANOVA, it's not doing it. Like it doesn't just automatically do it. So she's trying to figure it out. But I'm okay with just putting true for both. And I'll submit mine
Okay.
first so that you guys can put the right answer.
Oh, that's fine. Don't they have to be equal? Isn't that a thing? Or they have to be like normal?
I think so,
Is that part of
but
it?
I think so.
Because if we know that answer, I mean, we don't have to worry about the other part.
Yeah, it's weird because, oh, they're both true. So the only thing we
Okay.
got wrong is number 9.
So it'd be false.
So it's false, yeah.
So for number 15, the test statistic, that's the right skewed, right?
Right. I believe it is always right. Correct?
That's what I remember reading. Okay.
So yeah, you guys can change 9 to false, and then you should get 100.
Cool.
Sweet.
Okay, now let's do lesson 15.
Okay. So how are you guys going to figure out how to do QQ plots from Excel for the test?
Ask my roommate.
Okay.
Yeah, I'm gonna ask I'll probably use my husband's SPSS on his computer
Yeah.
if it's like a huge deal. If not, I'll probably just say true and get it wrong if it's false.
Okay.
I don't know.
Okay. There's 27 questions.
Oh boy. All right.
Well, there's 26 in the review.
Yeah.
So I can read number 2.
Okay.
Given a 90% interval of 45-105 for mean heart rate, which of the following is the best interpretation of this confidence interval? We are 90% confident that the true mean heart rate is between 45 and 105. There is a 90% chance that the true mean heart rate is between 45 and 105. 90% of all people have heart rates in between 45 and 105. There's a 90% chance that the sample mean heart rate is between 45 and 105.
Okay, this is my least favorite type of question, and I got it wrong. Like when I was doing one of the homework quizzes.
Wouldn't it be the last one?
That's what I put a little mark next to on my paper here, but I wasn't 100% sure.
I thought it was A. I put A, but I don't know. I don't know. I think the only reason I say A is just because the 90% confidence interval would mean that we're 90% confident.
Yeah.
But
So I guess the difference between those two is it talking about the true mean or is it talking about the sample mean falling within that range?
oh. Well, I'm pretty sure that the reason that we do these like 90% confidence intervals is to try and figure out what the true mean would be. Because it's like, it kind of goes back to that population versus sample size. Like, you're getting a sample size that's only maybe 30 people, but you're saying that it is over the entire population of the United States or something.
Right.
I think that A makes sense, just for the fact that it does say confident.
Okay, let's go with that.
I'm not against that.
I got this one wrong on another one too, so don't trust me.
Okay. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to no-go stimulus of males differed from that of females. The researchers randomly selected 20 males and 15 males to participate. The go-no-go stimulus required the students to respond to a particular stimulus and not to respond to the other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create a QQ plot of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? Yes, the distribution of the mean for each sample is normal. The researchers can apply the sample limit. Yes, the distribution of the mean of each sample is normal since the data have been determined to be normal. No, the distribution of mean of each sample is not normal since the sample size is not large enough. No, the company the So the population is 35.
Right, so that's, and they combined males and females together for their numbers, right?
Yeah. So it could potentially be A. I think it's yes. I don't think it's no.
It is yes.
Mm-hmm.
Because, why did I put yes?
I think it's A.
I thought it might be B, but
Okay.
again, don't trust me.
The only thing about B is it doesn't tell us whether it's, like it doesn't say anything about it being normal to begin with. Like they do a QQ plot and find that, but.
Oh, okay.
That's what I thought. That's true. So could it be C, that the sample size is not large enough because it doesn't need to be 30, but I guess we have 35.
I feel like it's A. Can you apply the central limit theorem to this?
Well, our sample size is bigger than 30, so I think so.
That's what I would put. I don't know. I could put yes for that one, and if you choose a different one, I could submit first.
So you're putting A.
Yeah.
Okay. And real quick, did you guys already go through the whole review, or have you gone through just bits and pieces, or?
Bits and pieces.
Yeah, have you gone through the whole review?
Yeah, so I have all my answers, like, on a Word document.
Okay.
So do you know what's
true? I have it printed out, and then I have things circled.
What was that?
Oh, I printed out a copy of it, and I wrote some notes and circled some answers.
Oh.
You don't know, neither of you know if they're true or not, though, right?
Right. It's just what I have done before.
Yes, there's no answer key to check it with.
Yeah.
Okay.
So, would you prefer to go over this tomorrow after I have more time to look at it, or do we want to just work through it?
I'm personally fine with doing it like this.
I got permission to take the test tonight, just in case something happens with having the baby early.
Okay. Well, I mean, I'm fine doing it now, but I just don't want you to feel like you did the work and then we're not like contributing.
Right. Well, I think it'll definitely be helpful. I think we might as well just do it tonight if you guys are okay with that.
I'm fine with that if you're okay with that.
Mm-hmm. Totally.
Okay.
It'll help review more.
Okay.
And you don't have to immediately give us your answers, you know what I mean? Like, maybe we can work it out, and then if you definitely think there's something different, we just do it together.
It'll be good for me to hear what you guys think, too, because, like I said, I'm not confident on, like, any of them, so.
Okay.
Yeah.
All right.
Okay, so I can You're ready.
Okay, so it says, of the 4 types of confidence, or wait, sorry, I'm reading off my paper.
That's okay, I think it's the same.
It's the same.
It is the same?
Yeah.
Yeah.
Okay. So, wait, did we pick an answer for number 3?
Yeah. Well,
I think we chose A.
We're choosing A, right?
Yeah, I picked A.
Okay. So number 4, of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? So I think we need to decide what information we have, right?
Right.
So we do not know the standard deviation, I don't think.
No.
So
Right.
A is out.
Yeah, so A and B, like, that's both. Well, standard deviation is that U one, right? Or is it the circle with the tail?
It's
a
sigma.
circle with
Standard deviation is the circle with the tail.
Okay. Well, A is out because we don't know that.
Do you think these are so it looks like they've actually separated male and female into 2 different samples, right?
Mm-hmm. Well,
That's what's making me believe based on this question. And so they're not dependent because group 1, let's say that was female, does not determine group 2, so C is out.
yeah. Yeah.
Mm-hmm.
So it's either B or D. I don't really understand B. We're
don't
trying to find
understand-
the confidence interval. Would you put this, like, let's say you have the information from all of the 20 females and the 15 males. Would you put it into that type of graphing system that we have? Or would you do an equation?
We had an equation a few lessons ago where we could calculate out if you didn't know the standard deviation, right?
We don't have the confidence interval, though.
Oh, true.
But based on the, okay, that's a good point. But based on the information we have, can we create a confidence interval?
Probably. It's usually 95% confidence.
Well, the
level,
confidence
right?
interval is going to be the 2 numbers. It's not going to be the 95%. It's going to be like 23, comma 56 or whatever the numbers are.
Oh.
It's that one where it was like, let me see if I have the note card on me. It might be in my car.
Well, I think for number 4, I'm changing my answer because of what we've discussed. But, like, if we were to put this... The first one I had was B. But I think now, like, looking back on it, since there's 2 different samples, like, from males and females, that it's going to be...
I'm personally going to be putting D.
Okay.
I mean, obviously, if we find something that's, like, totally different than that, then I would change it, but...
So, Alyssa, are you putting C then?
Oh, no, D, because they're independent, right?
Yeah.
Yeah. Okay, yeah, that makes sense.
I mean, yes, sigma is unknown, but D, I think, is more appropriate.
Yeah.
Sounds good.
Okay, so 5 says a researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be those 2 numbers. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? A. Obtain the savings account balances of only 10 bank customers rather than 30 because 10 are likely to be more uniform than 30. Obtain the balances of 90 bank customers rather than 30. Compute a 99% confidence interval rather than a 95% confidence interval, or none of the above.
Okay, so do you guys remember what the margin of error calculation is? I might have to run out to my car because my notebook's out there. all my notes from this.
Is it the more that you do, the more cohesive it is? Like the
Like, the
larger
more
the sample size, the more cohesive.
So yeah, as the sample size increases, the width of the confidence interval decreases.
So that would be a good, because if we just change the confidence interval, that's not really gonna, it'll change, but I don't know if that's what it's wanting to do.
I think C would work because, yeah.
Well, see, those ones are tricky because the level of confidence, as that increases, the width increases too. So 99% is actually going to make it less accurate than 95% would.
Do you remember what the equation is for the margin of error?
Yeah.
Because if we look at that, then we'll be able to figure out what will change that number. Like, we'll make it go up or down. Because it'll be the denominator.
The sample size is going to make it go down. The sample size is going to make the margin of error go down. So it's going to be less in between. Like, does that make sense? So instead of it being 3402.08 and 4142.75, it could be like 3403 and 4142. That makes sense?
So then that would mean that A is the answer?
I mean that
Yeah?
B, right?
No, I think it means that B is the answer. Because when we increase the sample size from 80 to 90, then the width of like how much margin of error we have is going to decrease.
Yes. Okay. Yeah. All right. I can read the next one if you want.
Okay.
A factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are shown to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts.
I have a question about what that equation is again.
I'm looking it up right now. So it's X bar plus or minus Z star times the standard deviation, and wow, the way it printed out was weird on this paper.
I know. So crazy.
Let me use the internet. Actually, I'm going to run out to my car and get my notebook because that has all the equations written down, and that'll be really helpful.
Okay. And I can show you guys too, like it's probably backwards, but it's this one.
Yeah, it's that one.
Okay.
It's actually a pretty easy one to put in. Like the numbers come out even, so it's really nice.
Yeah, I just want to make sure that I have the different equations for the test, because, and I can go back and find all of those, but I guess, like, since we're in it right now, that's something that I really want to make sure I have. We get to look at Washington.
What'd you say?
Oh, yeah.
Oh,
there's my house. I don't know if you can see it at all. There's a beautiful tree.
Look at that Washington tree.
With no
I've
snow.
never been to Washington, but now I feel like I have.
Oh, good. All right. So hopefully that should help.
I feel like my face is literally the same color as this right here.
I feel that way too. Like the light in whatever room makes a huge difference.
I mean, I'm pale, but I promise I'm not like that pale. I don't think they accept vampires into DOU, Idaho. So.
They should.
Okay, sorry. I'm gonna feel much more organized now that I have my note cards with all my equations on them.
Good. Good.
Okay, so we're doing the confidence interval. We're calculating it, right? So our x bar (1,000) plus or minus.
What's the equation?
Z-score for 95% is 1.96, right?
Yes.
Okay. And then our sample size was just 4, right?
Uh-huh.
Okay.
It is.
And our standard deviation was 2. Okay. So, sorry, did you already calculate this and I'm just like behind?
I already did mine, but that's totally fine.
Okay. So,
Okay, so the equation, sorry to keep asking this. The equation is x bar plus or minus t, and then it would be s over n, the square root of n.
Yeah, basically.
Yeah, because it would be the standard deviation over the square root of the population.
Yeah.
And then t is that number that... What number is t?
T is 1.96.
Okay.
Because it's the 95%.
I am totally understand now. Sweet.
Sweet.
So do you get it, Angela?
hold on 1 second. Minus. I got 998.04 and 1001.96.
That's what I got.
Okay.
So it would just be A.
I brought this for you.
Yay, I still remember how to do one thing. And that's
So
the thing I couldn't do that one day when the TA was with us, was when we were practicing these.
Yeah. That felt like forever ago.
Yeah.
I could read 7 if you want.
Okay.
Okay.
To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean u and standard deviation being 0.01 grams. How large should n be so that a 95% confidence interval for u has a margin of error of plus or minus 0.0001? And
Margin.
how do we do that?
So there's an equation. If you guys want me to tell you what it is, I can, or you can
So
find
we're
it.
trying to find how big a sample size should be. So it's the one that starts with
N.
somewhere. N equals Z star times the standard deviation divided by the margin of error, and then you square that.
It doesn't have to be the margin. Yeah, it is. Let me see what I did.
Is it z times s all over the
Yeah.
Okay.
Margin of error. Okay.
What is Z? What is Z the 0? Oh no. Is Z
Z
the
T.
0.00?
Z is 1.96 because it's the 95%, like the
Oh,
Z of 95%.
that's right.
1.96 times.
Wow, I totally forgot this stuff.
I know, right? I had to go back and review like lesson 10, I think it is.
Did you get a really large number?
Yeah.
Okay. Oh, where did that go?
As long as you get a number that's in the answers, then I think you're good.
So I'm going to tell you what I did, and then
I got the third one. Okay, what'd you do?
because I think I did it. Well, I did it wrong, but so it's supposed to be the 1.96,
Uh-huh.
and then you multiply, and that's multiplied by 0.01,
Yes.
Right.
and divided by 0.95.
Divide by 0.0001.
Okay.
That's your margin of error.
Okay.
So then you'll get like 196 or something like that.
Okay.
Yeah, I think it is 196.
And then you
Can't remember.
square that.
I was just looking at the wrong number.
Okay.
Perfect. Okay.
So then it should be 38,416.
Okay.
That's what I got too, so hopefully,
Okay.
hopefully it's good.
Does someone want to read 8?
Sure.
I can read it. Oh,
Go for it.
just kidding. Oh, there it is. Okay, so it says the mean area mu of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis are.
I feel like it would be.
A for that one.
Yeah, I feel like it would be. Oh. Maybe.
That's what I said. Just
That's
because
true.
he said that he wants to find if they're smaller.
Lower. Okay, yeah. Okay. Number 9. In a statistical test of hypothesis, we say the data are statistically significant at a level of significance if A is 0.05, the p-value is less than A is small, the p-value is larger than A.
I put B. You put what?
I don't know this one. I put A or B.
Okay, so I had put B, and I'll try to explain it, and I may decide that that's not true or not. But so when you have something that's significant, that means then you can reject the null hypothesis, right? Because you have enough information to prove something's different than it. So when your p-value is less than alpha, that's when you reject the null hypothesis.
Okay, I can fix that.
Above, then you refuse to reject, right? When it's high, you refuse to reject, and when it's low, you reject.
No, you're totally right.
But I'm not sure.
I agree that it's B.
Yeah, I think I'm totally fine doing that. Putting B.
Okay.
And then, where are we at? 10?
Mm-hmm.
Okay, so this one's tricky too. It says a group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer their question?
Do the sample variances need to be equal, or is nearly equal okay?
I do not know.
Do they need to know the true standard deviation? That's the only thing though, like I feel like
Okay, it says we can conduct ANOVA testing when the following two requirements are met. The data is normally distributed in each group, and that was true in that, right?
I think so.
Yeah, because they're saying it's bell-shaped, so that's, I think, what they're saying with that. And then the largest variance is not more than 4 times the smallest variance. And so if they're nearly equal, then I would think that it's smaller than 4 times.
Mm-hmm.
So then
So
I'm
it's
going to
all-
say, yes, we could conduct the test.
this would be A.
I would think so.
Yeah, I would think that it'd be A based on that.
Okay. Sounds good.
I wish we could take the exam together.
I know.
I know, right?
I do a heck of a lot better than last time. I can read 11 if you want.
Okay.
A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In the early trial, she tried a new treatment on 3 subjects who had an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis in a future study. It is determined that the new treatment does not increase the mean survival time of the population of all participants with this particular type of cancer. The researcher has committed a type 1 error, type 2, incorrectly used the 0.05 significance level when she should have used 0.01, incorrectly used a 0.05 significance test when she should have completed the p-value.
Yeah, I'm thinking it's a type 1 error, because type 1 is when you reject a null hypothesis that in reality is true. So they thought they had enough evidence to say that the alternative was true, but then it turned out to not be. Right?
Yeah.
And then a type 2 is when you fail to reject a null hypothesis that in reality is not true. So I'm thinking it's a type 1 error.
That's what I
Yeah.
That's what you put? Okay. All right. Do you want me to read number 12?
Yes.
What?
Sure.
Okay.
Yeah.
If the level of significance alpha is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error?
Well, I feel like isn't there
I think it would increase your chance of doing that, right?
Of committing a type 2 error?
Yeah.
Mm-hmm. It does.
So I would put D. Shaylee, does that make sense?
Yeah. Yeah, it does.
And here, I can give you guys this in our chat. Let me get to you guys. So you can copy and paste that into your notes if you want it.
Okay.
It's gonna go. It's just like the. And did it? I don't think it's sent. It's just like the definition of what that is. Hopefully it comes through soon.
Okay. Oh,
Right
and
now
now
your screen is black. So
now she's gone.
is she gone completely? No, well, it's saying she's still there.
Oh, okay. Yeah, her little box on my screen is completely black and doesn't even have her name in it.
Yeah, if you roll your, well, when I roll my mouse over it shows it. But yeah, that's weird.
Oh, I'm on my phone.
Come back, Alyssa.
Oh no. Do we need to try calling her, or will she be able to add herself back in?
Maybe I'll try to invite. Can I do that?
Not
I don't know if I can do it since it's not my call.
Right, it's her call.
Yeah, because her name's completely gone now.
Yeah, it said on my screen that she left the call.
How weird. I'm hoping she's feeling okay. She
Yeah.
looks like she wasn't feeling very good the past few minutes, so.
Yeah.
Okay, let's see. Let me know if she texts you. She hasn't texted me yet.
Okay.
Do you want to keep going since she's already done all of it?
Oh, she joined the call. All right, perfect. Maybe. I'll read number 13.
Okay.
It says the nicotine content in cigarettes of a certain brand is normally distributed with a mean in milligrams mu and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of the brand give it a sample mean of X bar 1.53. Is the evidence that is the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis. The null hypothesis mu equals 1.5, and the alternative is mu is greater than 1.5.
Can you guys hear me?
Okay. So,
Yeah, I can hear you.
Okay, that's weird. My thing like ended and now it just randomly came back on, but cool. Nice to be with you guys again.
Yeah.
Thank you.
Okay. For this one, at 5% level of significance, you can conclude that we reject it, we fail to reject, well, we reject the, words. We reject, is HA the hypothesis or is it the null?
The null hypothesis is the H and then the little O or 0.
Okay.
And then the alternative is the A.
We reject the alternative. We fail to reject the null. There's a 5% chance that the null hypothesis is true. Reject null. These are the ones that get really confusing.
Yeah, I agree.
In order to know if we fail to reject or if we reject,
5% level of significance.
Right?
What were you saying?
When it says that there's a 5% level of significance, does that
Did she freeze on yours too?
Yeah. Can you hear us? Oh, she went away.
No, she's like totally frozen.
She went away on mine. This is so cool. I feel like we should get like an A for effort or something.
Seriously. Oh, now she's gone on mine.
What were you gonna say though about this question? I feel like you started saying something, but I couldn't hear you.
Yeah, I was just saying that we would have to know whether or not to reject or fail to reject, we would have to know the p-value, don't we?
Yeah, which we don't.
Right. So does that mean
Would
that
be
it's p by default, or does it mean that we have to find the p-value?
yeah, I don't know if it's number C or
Because how do you find, where's my notebook? We have that. How do you find the p-value without putting it into Excel?
I don't know.
Me neither. Maybe, I'll try to send her another invite just in case she can't get back in. I'm bad, but I'm really okay just getting to you.
What does the level of significance mean?
Level
Like,
of
at least
significance.
for Christian.
So the level of significance is alpha, I believe. So when it says like up in 11, how it has 0.05 significance level.
Yeah.
So that would mean that it's a 95% confidence interval.
Okay. So 5% level of significance. That's difficult because I don't know which one that would end up being.
I know. 5% in decimal form is 0.05.
So that would be a 95.
Yeah, but that doesn't help either.
Did you have an answer for this one?
I have C question mark. So I don't know, because I didn't know which other one it would be. I didn't know if it would be A, B, or D based on what we have.
Well, I'm comfortable with just putting that for now. And then if it's wrong, then obviously I'll go back and see about why it would be wrong.
I'm okay with that.
We can go ahead and go on to 14 and wait till she can come back, and once she comes back, we'll go from there.
Okay.
You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? It would be a paired. No, an independent sample is t-test.
That's what I said.
Because they're not paired. It doesn't matter where they are.
Yeah, right.
Yeah. It just matters what the final outcome is.
Right.
So that's what I would go with. And there's not like a bunch of them, so it wouldn't be a NOVA test.
Right. So you said independent samples, right?
Mm-hmm.
Okay.
Yeah,
15.
15. Do you want to read that one?
Sure. It says an educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. She should use a hypothesis test based on independent or dependent sampling. Definitely dependent.
Yeah.
And then, so that makes it either C or D. So the sister's academic achievement depends to some degree on her brother's academic achievement. Or if you select a brother, so as to compare his academic achievement to his sister, you must include the sister in your study.
I'm not. I want to say D.
That's what I have, and I think you're right because you can't for the C, that's
I
what
don't
you're
think
trying
the
to
brother
compare.
has anything to do with the sisters. Like, I don't think that's what they're looking for.
Yeah, that's what they're trying to find out. So I think it's D because
Yeah.
the brother depends on the.
Yeah.
I'm gonna.
Have you gotten
I'm
a
gonna
text from her?
Have you?
No.
Yeah. Can you put that off speaker? I'm just gonna text her in the group, or should I text her individually?
I would do it individually because I guess she's not getting her text messages as of today.
That stinks so much.
Yeah.
Oh no, did I lose you too?
No, I'm here.
Oh, you're still there. I was like, ah!
Yeah,
Okay.
I was just very still.
That's okay. Do you want to read 16?
Okay. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon levels in the field. Open the data file dissolved organic carbon. Use the information to answer questions 16 through 17. So I know how to do this, how to open it. So first thing I'm gonna I'm just gonna look at it really quick. I'm gonna look at 16 and see if I can answer it.
Okay.
This time it's on my computer, so
Okay.
Here.
So what number were we on with you? We were on
I think we were
13.
13, and then I started working ahead a little bit, but let's go to 13.
So we picked C.
For 13, you picked C?
Uh-huh.
Okay, how come?
Because you need to know, what was it that you needed to know in order to be able to...
The p-value?
Yeah, the p-value. You need to know the p-value, and we don't know what the p-value is.
Okay.
So that gets rid of the other three.
Okay. So number 14, I'll read it. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? So on that one, I put independent sample t-test.
Yeah, we did too. We went ahead also. So.
Okay, good. And so for 15, I put D.
Yeah.
Okay.
Same.
And then I was just setting up 16 to work on that one.
Yeah.
Perfect. That's what we did too.
Okay.
So let me see. I have to find that data file really quick.
Well, do we even need it for number 16?
That's what I was wondering. I don't know if we actually do need it for 16.
We might need it later.
We might need it for 17. Well, we'll need it for 17. But,
yeah.
The 4 types of confidence intervals listed below were situation. Confidence interval for you, or sorry, I don't know their actual names.
That was right.
For you, is that sigma?
Uh-huh.
When sigma is known. Confidence interval for you when sigma is unknown. Confidence interval for the mean of differences using dependent samples. Confidence interval for the difference of means using independent samples.
So one of the tricks that I do for this is I just figure which graph or which sheet I'm going to put my stuff into. And depending on that is what I get for my answer. I don't know if that makes sense. So like,
Yep.
we'll put this data into the one sample.
Yeah.
So that tells me that it's not dependent or independent. And because we don't know sigma, that it's got to be B.
Okay.
Okay.
That's my like little trick. I don't know if it makes sense for you guys or not, but
No, yeah, it does.
maybe it'll make sense when we go to the next few.
Okay.
Okay. So next for 17, which of the following is the 95% confidence interval? So what are we, so for this test, we're not comparing two independent or dependent means. What are we testing?
So you're just trying to find the margin of error, basically, like the, what is it called?
So just do
Like
a
the
one
lowest
sample t-test?
higher range?
Yeah.
Mhm.
One thing.
Yeah, that's 16 is B.
And then do we do it for 14 days or 90 days?
What?
Did I open the wrong one?
Maybe. Is yours the dissolved organic carbon?
Oh, wow. Nope. This looks like airport things. Let me go back. I must have more than one thing open.
Airport is the next one. Yeah. It's like 14 or 90 days.
Let me go back.
That makes so much more sense. Here's the next one.
So what's the name of
And then
it?
what?
Dissolving,
It's,
dissolved organic carbon, right? Okay. That
yeah.
will make more sense.
So I got my answer whenever you're ready.
Hold on just a minute. Sorry, I have to open the right thing. Analyze reports. Okay, so would it be 11.168 and 15.217?
Yeah.
That's what I got.
Okay, perfect.
A random sample of Hummers for sale in Los Angeles and New York were taken from listings at Cars.com. We want to know if there is a difference in mean listing prices between Hummers for sale in Los Angeles, Group 1, and Hummers for sale in New York, Group 2. Create a 95% confidence interval for the true difference of mean listing prices between two cities. Open dials. Use Hummers, LA, New York. Use this information to answer question 18 and 19. Well, I believe that we can answer question 18 without having, before we do all of the work.
Okay.
Yeah.
I feel like it's C, but I could be wrong.
You feel like it's C? Is that what you said?
Yeah.
Hummers and sales in New York.
So
I think that they're independent samples, aren't they?
Yeah.
I think so.
Sorry, that's what I meant, not dependent. Sorry.
Okay, so then it would be D.
That's what I think.
Okay.
That's the like the chart that I used. I used the independent and not the dependent one.
Yeah. Okay, let me open up the file and then see if I can, oops, get the chart. So, Hummers, LA, New York. Okay. Hummers.
I actually don't know where that file is on mine.
I don't see it on my list.
Is it used? Used Hummers.
Used Hummers.
Okay, there we go.
The data is
This is one where we have to find the difference between it first, right? So,
Mm,
going to analyze.
It's just a 2-sample t-test, right?
But do we have to recode it first to
What do
make
you
our 2 groups?
I don't know what that means.
know what you mean. I
And
think
yes, it's just it's 2 sample. You're right. I had to go in and pull it up. I didn't know right away.
Okay.
I'm just going to be taking, so D is going to go in my first column, and then I'm going to put, wait a minute, what is going on? I know what I did.
Oops, test variable. So what was it? What's our test variable? It was the price, right?
Yeah.
Okay. And then the group variable will be the difference.
Yeah, so for variable 1, I'm just going to be, and then variable 2, I'll do New York.
Options, continue.
Sorry that you have to wait for hours.
Well, you guys are totally fine.
Okay. I got mine.
So when I put in my test variables as price and then the group variables is the difference. Oh, I know what it wants. Okay, never mind. Group 1 is 1 and group 2 is 2. Continue. Okay.
It's not equal to, right?
You're just finding.
Yeah.
Okay.
Wait, and what was the question asking us to find?
The confidence interval?
So I have negative 423.158 and 5,417.256.
Yeah, that's what I got, so it's just easy.
That's what I have too.
Okay.
Who wants to read number 20?
I can.
You can.
Many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones and causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups. Rats were selected at random for the 3 groups: a control with no jumping, a low jump group, and a high jump group. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of rats was measured. The rats were selected at random for the 3 groups. Researchers would like to determine if the mean levels of bone density are different between the 3 different groups of rats listed above. Use A equals 0.05 level of significance. Open the data file exercise bones density. Use the information to answer questions 20 through 23. So question 20 is, what is the correct hypothesis test for this situation? I think you would do an ANOVA test on this, right?
Yeah, because you have more than 2.
Because you have more than 2 means.
Yeah.
Right.
Yeah.
Okay. So the data file is exercise bones density. Exercise.
I'll be right back, guys.
Okay.
Okay, so I have completed that.
I'm almost there. Oops.
What did we get for 20 again?
Hold on 1 second.
No, okay.
Yeah. Okay. Okay, and what are we looking for this question? Sorry.
The statistic.
The what?
The test statistic.
Okay, so did you get an answer of 0.004? I don't know if that's the right number.
I'm actually trying to find where the test statistic is.
I think it's the SIG, like I think in mine it's like SIG, and it's that.
In ours, for different. So in ANOVA, it's
You're breaking up a little bit.
Can you hear me better?
Yeah.
So you're asking about the test statistic, right?
Yeah.
So it's F.
Okay, so 7.978.
Yeah.
What did you say you got, Angela?
Oh, I was looking at the wrong thing. You said it's under S?
F, like Frank.
Oh, 10.174.
I don't know. Yours isn't an answer, so I'm not sure.
Right, so that means I'm wrong, but
we got 7.978.
7.978.
Did you put in? Do you have 3 different?
Yeah, I made 3 different groups. Let me try one thing differently. I'm going to try switching which one is the factor and which one's the dependent and see if that makes a difference.
Okay.
My p-value is wrong though, so.
Options, descriptive means plot continuum. Okay. So now it's giving me F of 7.978.
Perfect. That's what we got.
Okay, so let me write down, how do you decide which one is the factor and which one's the dependent?
Mine doesn't have factor independent. Mine's just
Yeah.
variable.
Yeah. So I did actually get the p-value right. I just rounded it wrong. Do you know what your p-value is, Angela?
The p-value is 0.002.
Yeah, that's right.
Okay.
That's what I mean.
We're so close. Being done. Are you ready to move
We only
on?
have like
I'm ready for 23.
Okay. Alyssa, did you want to read it?
Yeah. It says, which of the following best expresses the conclusion of this test? Use a level of significance of A equals 0.05. So our level of significance is lower or less than that.
So
our p-value is less than that.
Mm-hmm.
So it's going to be A or B, right?
Yeah.
So when the p-value is low, we reject the null, so we have sufficient evidence, yeah.
So what was
I would say that it'd be B, because we don't know which one specifically is which, right?
No.
Like, we just know that one of them, at least.
Well, I know.
I would guess, yeah.
Because we know, like, what is the null and what is the other one?
The alternative?
The alternative.
I don't know if it told us.
We could go.
The null. Oh. I tried figuring this out too before. Don't really get it.
Okay, let me look at the question.
So it says researchers would like to determine if the mean levels of bone density are different between the 3 different groups of rats. So that's our alternative, I think.
And so it would be B because we're accepting that.
Well,
I
A and
think
B
so.
both accept that they're different.
Well, I mean, like, we're accepting that at least one of the groups is different.
Yeah.
The bone density of at least one.
Yeah. Yeah.
Okay. I can read the next one.
Okay.
Pressures of supply and demand act directly on the prices for an airline ticket. As the seats available on the plane begin to fill, airlines raise the price. If the seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with the ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance and then again 14 days in advance. Perform a hypothesis test to determine if there is a difference in the cost of nonstop flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use the level of significance A is 0.10, so it'll be a 90%.
Confidence interval. Okay.
So what is the hypothesis test for this situation?
So I would guess that it is
Dependent? Do you think it's dependent?
yes, because you're picking the same cities. You just have different time periods that you're doing, different days that you're
Yeah, it
doing.
has to be the same flight. It's just different
Yeah. So they're
days.
dependent, right?
Right.
Okay.
Yeah. And then we have to calculate all that stuff.
Okay. So
Let me find that. Let me open. I have so many things open in Excel right now.
I do too. What was the name of the file?
Flight costs.
Flight costs.
Direct flight costs.
Direct flight costs. Okay.
Okay.
Transform.
So this is a paired sample, right? T-test?
It's an independent, or no, dependent. Yeah, paired samples t-test. Yeah.
Well, what was the first question again? What are we looking for first?
Test statistic.
Okay.
Oh no,
So,
I lost my thing.
I got 1.685.
What did I have?
I'm looking at the right thing. Yeah, okay.
Analyze. Compare
Did you
means.
lose it?
Where did it go? I got 1.685.
Yeah, so did we.
Okay.
And then for the p-value, I got 0.096.
Me too.
Same here.
So,
Yay.
which of the following best expresses the conclusion of this test?
Oh wait, did you change your
Level of significance?
yeah.
Let me check.
I just realized I did not do that.
I didn't either.
I did it on mine,
You did on yours?
and the answers are
Oh, this is like the other day when we realized that it didn't matter. Right?
yeah.
Just for those
Changes
specific
the-
values.
It just changes the confidence interval.
Yeah.
Okay, sweet. So there is sufficient evidence to conclude that there is no difference in the cost of ticket prices 14 days in advance compared to 90 days. There is sufficient evidence to conclude there is a difference in cost. There is sufficient evidence to conclude that there is no difference in cost between tickets purchased 14 days.
It would be B, wouldn't it?
I think so, because we're rejecting the null.
Mm-hmm. Which means that we're saying that there is a difference. Well, what was the null?
Yeah, you're right. Because the alternative, it's saying that they're doing the test to determine if there is a difference.
So I
In the
submitted
cost.
mine, and that's right.
And
Okay.
sweet.
We
How'd we do
got
on everything else?
13 wrong. So 13 is reject and null.
Okay.
So D.
Why is that?
I'm not sure.
3
Is that because?
B.
Wait, which one are you saying?
3 is
So
B.
number 3, yeah.
So should we take a look at those again real quick and talk about them?
Well, 3 is easy.
Three. I thought B in the first place because I don't understand central limit theorem still, so I was more confident putting B, but
Okay.
So
And then 13.
so
Did we need to do a calculation to figure that out?
that's what we were discussing when you disappeared. Because the only way to figure out how to reject the null is if we have the p-value, right?
Mm-hmm.
Up against the significance level.
what's the equation for the p-value?
I don't know. I didn't know that there was one because I thought it was just what we put into our spreadsheets.
Do you know, Angela?
I do not know. I just know that it's all the area outside of our confidence interval.
Okay, well maybe we could just look up the equation for that. Like, even if it's just on our own. Like, I think that's a big factor.
Well, because we have, let's see. We have a lot of information in the answer or in the question.
Mm-hmm.
Because we have X bar, we have standard deviation, we have the sample mean or the sample size.
Well,
So do you think if we found the confidence interval, then we could figure out the p-value?
I don't know. I really don't. Well, because we have the standard deviation.
I'm going to share my screen.
Sheila, were there any others that we missed other than those two?
No.
Nice. Good job, guys. Yeah.
So I did find something.
Let me see if my husband knows. Hey, Levi. Will you come help us with this question?
Can you see my screen at all?
It's just black.
I can see you. I can just see you. Oh,
Okay.
now it's black.
My back.
Yeah.
Now can you see my screen?
Yeah.
So, do you remember that team? This is the only one I could think of.
The z-score. Yeah, that's probably right.
What if we used the applet?
Yeah, I think we would put the z-score that we get from this equation and then figure out the area.
Well, because the only way that I know how to reject or accept, or I guess fail to reject, the null is when the p-value is less than or greater than 8.
But if we get a z-score, then we can figure out the p-value, right?
I think so, because the p-value is like the area, right?
Mm-hmm.
Under the curve.
I'm going to try to do it right now.
Okay.
So we hit then C.
Do we know what U is?
We know what x bar is, which is 1.53. That's the sample mean.
Oh, I know what it is.
What do you do? Find z-score and then put it in the app.
Not sure. Just, do you know why you reject, what it means when you reject the null?
Yeah, it means the p-value is less than the level of significance.
But what does that mean? So you measured these and they're a little bit bigger, right? There they are. That's what it says.
So I got an answer.
On the paper, it says
It equals 1.17.
reality 1.53 is what it
1.17?
is.
Yeah.
So half of a difference. It's like if that was 2.0, that would be a huge difference.
Mm-hmm.
But then if it's
But if it's larger than 1.5, then we would fail to reject.
But it's greater than
Yeah, we reject the null.
like it falls outside of the range.
So U does not equal 1.5. It equals 1.17. Actually 1.18.
Okay.
Is that even on?
So we reject the null.
Cool.
So that makes sense. You just have to do that.
So my husband just explained it as well without having to compute anything.
Okay.
You have to.
Oh, you do have
Just
to?
explaining what it is.
Oh, he's just explaining why it is the answer that it is without the computing. But anyway, because so it talks about the mutant is 1.5,
Mm-hmm.
But then it says that the sample mean is 1.53, and that is greater than 1.5. Just barely, but it's still greater. So that there's enough of a significance that we would have to reject it.
Okay.
You know it's enough because you calculate it and find it.
Yeah, and you can only know that once you calculate it and find that it's less than 0.5% or 0.05 or 5%, I guess.
The probability of getting that.
So are we comfortable with this?
Yeah, I feel good.
Yeah, I think I'm good too.
Awesome. Thank you.
Sweet. All right, guys, good luck on the test.
Thanks, you too.
Thanks.
Okay, bye.
See ya.